Good afternoon, ladies and gentlemen. A cordial welcome to the International Space Science Institute to ISSI in Bern. My name is Michael Rast. I'm the Earth Sciences Director here at ISSI, and I welcome you to the 6th edition of our Game Changer Seminar series, Viewing Earth from Space, the Changing Environment and Climate of Our Planet. I'm particularly happy and welcome Professor Dr. Jackie McGlade. It's actually not easy to get her to those events, and I'm very happy we could twist her arm to come and give her seminar today. Jackie McGlade is professor at Strathmore University in Kenya, and at the same time also at the Institute for Global Prosperity at the University College in London. Jackie co-founded Downforce Technology, which is remarkably actually a global startup, not a regional or local one, providing advanced analysis and digital twin of land surfaces for investment and net zero nature-based transition. Prior to that, Jackie was UN Environment's chief scientist, executive director for the EEA, the European Environmental Agency, and she also was the director of UK Centre for Coastal and Marine Sciences. We got to know each other through her advisory role that she carried out in countless meetings for the European Space Agency, but also for the UK Space Agency. And she has, in that capacity, also been very deeply involved in the definition of the European Copernicus program's Sentinel missions since they basically set out. Currently, her focus of her research and work is on climate adaptation and mitigation in the MaO Mara area in Kenya, but also in the UK. Jackie has over 200 publications, and Planet Rethink and the Netflix Our Great National Parks belong to her award-winning films. There are too many science awards that Jackie obtained to count them all, and I'm very happy to have her here today giving the talk, Embedding Space into Natural Capital Stewardship and the Global Carbon Markets. Before I hand over to Jackie, I just wanted to say, if you have questions to Jackie, and I'm sure there will be many, please put them into the chat. We wouldn't want to interrupt her presentation. And after her presentation, I will read the questions out to her so that she doesn't have to watch the chat. So questions, please, into the chat. And again, Jackie, a cordial welcome, and the floor is yours.
Michael, thank you so much, and Tillman. It's a huge pleasure to be with you this evening. I'm going to just share some slides, some pictures about what I do, and to give you some ideas about what I'm going to be talking about. So I'm hoping that many of you will have heard of natural capital. It's effectively our land, water, clean air, but it's also biodiversity, and how essentially we live on planet Earth is the way that we use that natural capital. But I'm going to talk this evening about how space is a key driver in the possibility of creating stewardship and also in the global carbon markets. So quite a mouthful, but anyway, let's move on. So at the last year's COP for the climate, COP26, that was held in Glasgow, there was, to my, I guess, say relief, a shift from what were previously seen as the big solution spaces for cutting greenhouse gas emissions, that's energy, industry, buildings and transport, and a realization that we needed to look very carefully at agriculture and also nature. And so the phrase nature-based solutions emerged as the, I guess in a sense, the planetary saving piece, which is how to create sinks for carbon. And as you can see here from the quote from UNEP, by 2050, the total investment needs of nature will amount to United States dollars 8.1 trillion and will be over 536 billion annually. The crazy thing is that since last year, there's already $3 trillion worth of investment sitting there. So all over the world, people who are seeking carbon offsetting opportunities, investors who are looking for ways to, I guess, secure their funds, are coming into this space. And as Walmart and many others have said, it's a regenerative approach that's going to actually provide around a third of the solution to climate change. So what's not to get? Well, businesses and investors are seeing the benefits of this kind of approach. Whether you're managing natural capital, whether you're in supply chains and trying to create transparency, whether you're in the core of the carbon markets, or maybe you're a bank that is actually looking to create green loans. So there are many, many sort of parts of society that are looking to, come into this area and to think about it, whether it's branding or ESG reporting. Stakeholders, shareholders, regulators, they're all looking for the net zero journeys of many companies and even governments, products that need labeling of their carbon footprint, and then whole supply chains that are, in a sense, being pushed towards net zero. In other words, taking their emissions and their offsetting and making sure that at the end of it, there's a net zero so that we can almost bottom out and go below the amount of emissions there are. Now, if you notice in the middle, the Space for Green Future Accelerator, this was an idea on the table with the European Space Agency, but effectively it works for the entire global space community. Because in a sense, what we're saying is that we can do and create different kinds of solutions with the sort of data that we have coming through the Earth observation missions. So the first big step forward, given how much data are being generated pretty much every day all over the planet, is to think about how to use it in a good way, and in this case for natural capital analytics. So one of the things that I've been working on for the last year, and which led to the launch of a startup company called Downforce Technologies, was to take all of the in situ ground data that we have, and that covers soils, climate, vegetation, the geode, the lithology, and so forth, and to bring that together to create functional classes of land. But instead of just simply creating layers of data, to actually understand literally how the land is functioning. It's almost like, how does it breathe? How does it respond to the climate and so on? To build that through data fusion into a cube, a data cube, and then to be able then to create what we call a digital twin. So imagine the digital twin is a bit like, well, it is a twin of the land that you have, it's digital. But what you are able to do, and we can do this now through Downforce and through some of the interactions that we have a systems model, we have a hydrology model, we have a lot of data work, data fusion. We're able to go end to end. How was the land performing 5-10 years ago? And how is it kind of modulated by the health of the land? And then most importantly, what's it going to look like in the future? And the very different picture that we've tried to create is, instead of focusing just on the above ground, the trees that we've got and grasses and so on, is that the models that I've built and that with the teams is below ground. It's about the microbiology. It's how the microbiome itself is functioning. And as we know, and many of you might have been watching some of the David Attenborough series recently, what happens below ground is almost more important for trapping carbon and keeping natural capital healthy. So we're really looking at that health factor of the land through the lens of the microbial and the fungal communities. Having sort of got to that point, it is absolutely clear that with the scale and the consistency that we can generate, the sort of data we get from satellites, but also then building that into these kinds of products, for the first time, we're really able to build natural capital accounting systems. Why do we want these? Well, many users are out there. Governments have signed up within the UN system for the Sustainable Development Goals. And one part of the Sustainable Development Goals are indicators. And to support the spatial dimension of sustainability, we had over 20 years or so moved from the system of national accounts to the system of environmental accounts to the extension, which is a system of ecosystem accounts. And so now we have a framework, we have a sort of numerical and accounting sort of set of guidelines. Well, actually, it's more than guidelines, it's actually standards. And these standards are essentially being used by more and more governments to put onto the books. So not just trade, deficits and flows and so on, not just GDP, but now accounts for natural capital. So this beautiful image is actually in northern Kenya, it's Lake Turkana, and effectively these are all the different natural capital regimes. You can see extinct volcanoes, you can see older tracts of where there's been, the Rift Valley itself has come apart and so on. So all over Kenya, it's possible for us to come down to 10-meter resolution and actually build up the accounts to the point where they have real meaning at the county level and then at the national level. So natural capital accounting is very important, quite arcane maybe, but nevertheless a driver of the economy. The other thing that we need to do is to establish baselines. So some years ago, long time ago, I have to say, in the late or the mid 80s and going into the early 90s, many of you may know that the cod fishery collapsed. And I was working at the time for the federal government of Canada, working in Nova Scotia, this little piece of land sticking out here below Newfoundland. But I had an idea at that time that what was affecting the recruitment of fish, particularly this one, the pollock, was because it sort of lives in the water column itself, had more to do with how the ocean itself was operating. And these circles, these gyres, spin off from the Gulf Stream. And at that time in the 80s, we were just beginning to get our first sort of glimpses from satellites, from Earth observation, as to how the surface features of the oceans were operating. So I was working in Nova Scotia, and I was responsible for the pollock fishery, and I was responsible for a few others. But anyway, the pollock fishery was my bin that I had to look after. These are some of the fishing boats and the fishermen who were dependent on that fishery. And I sort of put up a hypothesis that the success year on year of the pollock fishery really heavily depended on the position of the Gulf Stream and the gyres and eddies that were spinning off. Because essentially, if you imagine you're a fish and you spawn and your eggs and they're fertilized inside the water column, and you happen to be, and you are, this is where they were spawning along this line, and then the eddy goes outwards, then you are not going to find your way onto the shelf, on the continental shelf, and find yourself a happy home and grow up to be a large fish. And so what I started to do was experiments where I would take one of the big federal fisheries research vessels out to sea, and we would go hunting for these eddies, and then we would see whether there were any little baby fish in there. And sure enough, they were filled with them. And so this was the first time really that the Earth observation was being used to really predict the size of the fishery. And it was an important fishery, had big commercial concerns. Unfortunately for ground fish like cod, it doesn't work nearly so well. And so we weren't able to use this kind of data to do the predictions that we needed. So at least for 40 years, 35 years, this has been a tool in the repertoire of that particular fishery. Now, the next so having got our baseline starting, so we're starting to understand, what does a failure look like in a fishery? What does it look like when it's at its boom and bust? So here we can begin to really understand what's driving it, what's the causality. But you then need to try to connect natural capital assets, because of course these are ecosystem services as well, things like clean air, clean water, biodiversity, pollination, many things. And so sometimes I had the great privilege to go and work in very, very, very remote places. This is in Diego Garcia. This is the big air base in the middle of on the Chagos archipelago in the middle of the Indian Ocean. So here, of course, you could see there's a fairly well-developed human habitation, but everywhere else there's nobody. It's completely uninhabited. And so with this pristine environment, it was actually possible for us to see not only what was happening on land, so these are the boobies at land, and very tame, of course, because people aren't there, so they get used to approaching you. But you're able, because there's no human intervention, to really understand the connections between the big oceanographic systems and these small atolls that essentially emerge out of air and the sea. So you have seeds that are traveling in and different plants that are growing. So all of this carbon, all of this natural capital asset has, so to speak, been grown because of the connectivity that is out there. And that's an important part of building natural capital assets, to understand when you're doing the in and out accounts, what's happening there. And once again, being able to use Earth observation, it's quite easy to see when these atolls are being built and when they're being created and formed and as they grow and so forth. The other thing that Earth observation is incredibly useful for, of course, is detecting change. And the Arctic is a place where clearly a lot has been happening, not only in the changes in the sea ice itself, but also being able to connect what's happening vis-a-vis pollutants. So with seal tracking and many other sort of animal testing and so forth, we've really been able to show that not only is the way that sea ice is moving around very critical and the meteorology up there, but also the fact that the long-range transport of pollutants ending up as it does within the organs of mammals, marine mammals, which is very, very bad for a lot of the population that's living in the Arctic and their uptake of PCBs and so forth. But this big picture at the global scale and the global basin scale can be tracked and really shown to create an opportunity in the natural capital asset world of the sources and the sinks. So what does that really mean? Well, Earth observation, I think, is been around for a long time in this area, but what's now beginning to happen is that investors, bankers, others are realizing that we can use space, use Earth observation together with a lot of ground data to underpin the kind of investments at the scale that we need. So we have all around the world farmers who are realizing that they can't continue in the way that they have been, that they need to change the kind of farming they're doing, not only because of emissions, but just climate is being, it's a very harsh master, so to speak. So farmers are trying to move towards regenerative farming. And in that process, they need a lot more information at scale than they ever had before. As we move into industries that are transitioning, you need to be able to take that same level of accuracy and acuity into maybe 500 or at least 5 million hectares of land. Because when you talk about land degradation, this is really happening at scale in many places. So here in the Anthropocene, we can see this huge landscape destruction that's been happening. And the question then is, if you are to restore it, how can you detect the changes and so forth? And then at the sort of the other end, we see that investors themselves are opening up natural asset markets and supply chains and essentially saying to their suppliers, let's say we're looking at the dairy industry globally, then saying, well, within 5 years, you need to demonstrate that your dairy production is not only sustainable, but is going towards net zero emissions. So effectively, data coming at this scale means that we can have consistency all around the world, so that you don't literally end up with little niches of people measuring things in different ways. And that's always been the hallmark, I think, of space. It's been able to give a consistent set of data, no matter where you are. So in the transitioning, let's say to regenerative agroforestry, typically we'll see things like the impacts of set-aside, different kinds of ploughing, tillage patterns, moving into cover cropping, and all those effects on soil health. We can now occasionally we see papers that have got things like the tracking of methane. I'm not sure that's always going to be so clear, but there's the opportunity at least to do things like that. And then more traditional things of monitoring forest and land cover changes, and then looking now more and more at changes in crop rotation on yields. So surprisingly, when I look at this in great detail, when farmers have been doing very good rotation according to the book, putting in, let's say, lays, which are kind of like grasslands, and then lays to another kind of grass and pasture and so forth, it turns out that even some of those smaller rotations, that land actually loses carbon. And these are big surprises because, of course, farmers have felt that they've been doing the right thing, but now we have data that can actually tell them that they need to be very, very careful whenever they do rotations on their lands. We can also track things like air pollutants and emissions directly, not just in urban areas, but also in rural areas. And we can determine land quality for portfolio acquisition. So whether that's for new green infrastructure like solar farms, but we can also look at the impacts of solar farms on things like soil biodiversity and biodiversity with the kinds of level of data that we have. And I work quite often on projects where there is projected to be a large solar installation, lots of opposition quite often from people. But the point I often make with them is, given where the land is today, which is usually quite degraded agricultural land, putting solar into the landscape, albeit it's quite intrusive in some instances, is that it protects the soil, and the soil itself then has a chance to recover, to build up its own health. And soil has huge biodiversity in and of its own right. So if I'm honest, sorry, do excuse me. I had a small cough at the beginning of the week. So. Sometimes if I was worrying about biodiversity, I might want to relook at my thinking about solar panels and solar farms and think, well, actually, this is a kind of conservation set aside. We can also, of course, look at the impacts of climate events on biodiversity net gain. So the reason why I write the scope 1 and 2 and 3 is that these are the elements within the carbon trading and also the reporting under the UN framework on climate change. So 1 and 2 are your emissions in different contexts, and scope 3 is the sort of the insetting, or in some cases the offsetting. But most, I think, surprisingly, given where we were just even 2 or 3 years ago, is that there are now end-to-end supply chains looking for integrity from data that will underpin the idea that they can invest from end to end in terms of carbon, natural capital, and that this then lends them towards consistent global metrics for carbon markets and green finance. And so I'm working with one of the largest banks, or the largest bank in Australia, and a few others around the shaping of these green bonds, because for the very first time, using data at this scale and yet at this acuity, so from 10 meter up to 5 million hectares, same kind of consistent data. This means that banks and lenders and investors have a lot of confidence that what they're seeing is actually change that is real, but which can be tested and audited. But this can be done entirely away from the farm. In other words, they don't have to go and sample 5 million hectares of land. They can do this through a series of sort of financial analytics, but they're always looking at the farm, and they're looking at how healthy the soil is, how healthy the land is, and the same for conservation and so on. So it's really sort of transforming the way that not only farmers, but communities. And I'm just going to end with this last 2 slides. So the last 4 years I've been working in a very famous forest, the MaO Forest complex next to the Masai Mara. And in the top picture, you can see what this forest used to look like back in the 1960s and 70s. So dense canopy, beautiful forest, clean water, rivers flowing. Unfortunately, over the last 40, 50 years, 50% of the forest cover has been lost, 250,000 hectares, and about 3,000 kilometers of surface river water. Now, in this area, about 13.5 million, 13.6 million people are living in and around the forest, but crucially, 30 million people rely on the water from this water tower. So what has happened is that the government has taken quite a heavy hand and has evicted people, moved them out, and that's certainly having an impact. But what we've found over the last 4 years, whilst doing a lot of research on the ground, is that there is a sort of another way of bringing back that natural capital by making the forest the focus, but now enabling forest gardening, as we would call it, in other words, growing crops in and around and within the forest, or moving directly over to entirely carbon farming. And the map that you can see at the bottom, the 2 scenarios, are based on an underlying map, the one which is sort of red and yellow and green in parts, which is generated by Downforce from Earth observation data from the functional classes through a data fusion. And what this enabled the communities to do now was to determine where they would be able to derive the most carbon and the most benefits from natural capital by planting and regrowing forest, indigenous trees, medicinal trees, changing the sort of riparian areas, and so on and so forth. And so the idea really was, from the very beginning, was to increase the amount of carbon and carbon equivalents across the whole of the forest, and use the investment markets to pay for this and this stewardship, and to create a whole different kind of livelihood. Well, I'm very pleased to say that that has been happening, and through a sort of series of technologies brought together, we've now been able to do the following. So the direct outcome of everything was that the directors, the community leaders, have come together to create a natural capital company. They have designed and co-produced a platform on an app, which is GPRS connected insofar as they can go to the forest, they can map trees, individually identify a tree, say whether it's healthy, and that then uses the cloud, but there's a direct connection to the geopositioning, so we can actually have a very, very accurate positioning for all of the major and big, what I would say, the climax trees within the forests. And then this map they use to determine where they would try to put projects on the ground to restore forest. So using the data fusion and digital twin and analytics from Downforce, we were then able to come up with credible, additional, permanent, verifiable projects for carbon, and that could then go into the marketplace, which was looking for sort of transparency, something that was holistic, very fair and scalable. And why is it fair and why is it scalable? Well, it's scalable because each one of these projects has maybe got 400, 500, 600 households, all working, maybe growing 100,000 trees at a time, doing forest gardening and so on. And then the trees, what we do is we put these RFID nails into the trees, and they, through an Internet of Things, connect and tell us whether the trees are actually growing. We also have auditors who go out. We've trained lots of young people and lots of people across the community to be able to do that. But this tracking means that we can effectively, we have a blockchain platform now, which is supported by Microsoft and some others. We can actually offer up a 1 hectare, a sub 1 hectare piece of land with a person. And this goes into the carbon registry. It then goes into the voluntary carbon market where there are investors. And because we put all of this in, and it's sort of underpinned in a sense by space, and it's got our RFID and IoT, they can then comfortably, I would say, move money into the platform, which then through the mobile wallets, particularly the ones that we have here in Kenya, the M-Pesa wallet, puts that money directly into the phone of the lady who is growing the trees. So in a sense, this produces social good, real social good, creates an opportunity to restore the forest and bring all that surface water back. And at the same time is spilling off lots and lots of smaller companies, young people getting involved, new kinds of careers. And I really do believe that it's creating a new kind of partnership that is both rigorous, fair, but also could be repeated pretty much anywhere across Africa, anywhere across the world, indeed. So I'm going to leave it with that. I hope that's been a sort of a look into some of the things that we've been doing, and I'm very happy to answer any questions.
Thank you very much, Jackie, for this interesting look or glimpse or view into carbon markets, their partnerships and capital analytics leading to a global platform. I would invite the audience to pose some questions. Let me just see. I have here from Matt Payne. Thank you for a fantastic talk, Jackie. So there are some thank yous coming in. We are taking questions while we are doing that. Yeah, I always have the question in which way we see the different cultures grow together through what you have just shown in your carbon markets, in your carbon market perspective with the partnerships, the capital analytics, where do you see us go over the coming years? Are you totally optimistic, a little bit optimistic, or are you pessimistic? Sorry to ask such a naive
I think it's
qualitative question.
No, I mean, for this time of the day, it's good to have these kinds of questions, to be honest. So, you could pick up a newspaper anywhere in the world and you will see people pouring scorn, skeptical, greenwashing, this is just a whole joke. It's not really happening. What I think is going to be the game changer, quite honestly, here is that with the integrity of space and the Earth observation data that we have, and people know that, I mean, they rely on it in their cars to get them from A to B, for example, right? So with that kind of integrity and with public disclosure, for example, there's the nature-based financial disclosure process, TNFD. People all over the world are going to be able to pry and prod and ask and look for transparency, so that it's going to be very hard for companies to say that they have done something in the offsetting world and the carbon markets when they haven't actually done it. So that's the first thing. And I think this really is the game changer. And it's because of the way that space data is coming into this. It's sort of, I'm not saying that it's not value free, but it's just that it's done on such a scale, and people have got a very, very different attitude, I think, to Earth observation than perhaps to any other kind of data that's out there. Somehow the space agencies have managed to pull themselves away from the politics. And I believe that it's one of the sources of data that the public have the greatest confidence in. And as a result of that, because everyone's using Google Earth and doing all sorts of things with it. As a result of that, I believe that this is going to be the big opening up, not only of local things, but of big transnational corporations, because they literally won't be able to say things that aren't happening.
I have another two-pronged question for you. You know that at ISI we have different tools, one of which is free-ranging debates, which have a bit of an outlooking character. You just talked about the agencies, but when we, from ISI's perspective, as a science think tank platform, what would you give us as homework, as priority? Or if you were to have the chance to say, there is something I really would like to discuss, where I would really like to work on science involvement or the scientists' involvement into the future on that subject, on the stewardship in association with the global carbon markets, what would be your theme? What would you like to have us debate, discuss, or where would you like us to come up with a recommendation or a white paper or a direction into the future? What would be close to your heart, of course, under the umbrella of earth sciences and remote sensing?
Okay. My kind of reading, I was trained as a biochemist, one of my kind of things, and a plant biologist as well, amongst other things. And one of the things I realize and know very well is how the biochemistry of plants and vegetation, and essentially the whole planet, is out there to be carefully tracked and monitored. So volatile organic carbon, volatile organic compounds, I mean. Now, I am absolutely convinced that if you know you are feeling unwell and you walk into a forest, 9 times out of 10, when you leave that forest, you will feel better. Yeah. Walk out into nature, go on the shoreline, work on all these kinds of senses of feeling well when you get into, into the natural world. That is actually biochemistry that's going on. And what I would absolutely like in the coming sort of 5 years or so is to take what we've learned from Sentinel 5P and others, and to make a kind of connectivity, and maybe we're using CubeSats in between, I don't know, many things, but to make a connectivity of high-grade sensors in space and also on the ground, where we can connect up and we can talk about the health of the planet, not just through just the sort of the biomass and so on, but these more important signals. And the reason I say that is because when plants are stressed, which they're going to be because of climate change, they give out different compounds. And that would help us long before the plants start to show changes in their growth. Right. It would start to show us early warnings of the health of the planet, including ourselves. So that would be a fantastic earth science kind of project for us, I think.
Yeah. Oh, that would also play in with one of the forthcoming explorers, which look at the fluorescence and through
Exactly.
that health of plants before things show. But you made a very good point. There is panoplies of CubeSats and small sensors coming on, which actually in association, you used the term connectivity would really make a lot of sense. I got a question from Tilman Spohn here. What is the rate of global reforestation, if I may say so, that we see today? Maybe you gave that information and I missed it. And what is the effect on the carbon budget?
Okay. No, in fact, it's a bit of a depressing story. So I may get the numbers wrong. So let me just caveat all these numbers I'm about to say because it's off the top of my head. I know the potential and I know the kind of capacity. So tropical forests in Africa have the potential to store 6 petatons a year. Whether I could put my hand on my heart and say that that's being achieved in other parts of the tropics, so for example, in the Amazon and so forth. So, but what we do know is that the current rate of carbon sequestration in the undisturbed forests has been going up in certain parts. But everybody focuses on the tropics, yet if you look at where the biggest amount is, so that's because the trees in the tropical areas are very efficient. I mean, they're big and they're efficient and they have a rapid turnover and they're storing a lot of carbon. Up in the northern areas, in the boreal areas, even though each tree is relatively ineffectual, let me call it that, or it's not inefficient, it just doesn't do a lot. We have millions of hectares of forest. And so the Global Forest Watch is tracking this, and I'm not sure that I can give you the figure of what the percentage increase. There is an increase. However, it's being countermanded, so to speak, by fires and by loss of forest due to melting as the permafrost itself. And so the understory is actually collapsing. So that's a bit of a half-hearted answer at that. And I wish I had swatted up on that number before my lecture. But Tilman, can you make do with that for the moment? But the effect on the carbon budget is always present in terms of forests. But look to the boreal, look to the northern forests for the big bang, if you want to say, where the biggest amount of carbon sequestration is happening today.
Okay, thanks very much. Besides what you've just said, and also the plant health connectivity of sensors before, you mentioned the space agencies. You have been advising several for years. What would you tell them now where to go in terms of sensor development?
Oh, wow. Well, I think the one I mentioned about the sensors, if we could get closer and closer to plant health and vegetation and so forth, I think that has to be for me. So that's aerosols, it's down in that end, I think is really important for us. And in many ways that's being captured. I don't know. I must admit that I'm not saying I'm happy with the complement of what we have on the table with biomass and the other things that are coming online. I think we've got more than enough, so to speak, in our near future to be able to radically change the amount of detail that we can provide. So I'm saying that there's so much coming. Let's get on and learn how to use it, how to deploy it. The one thing I'm always very disappointed with is, well, not disappointed, but I wish more people knew how to use Aeolus data and that more of us were able to really put that to work. I think that was one of the ones that I was hoping would really spark people's imaginations and we would do more with it.
Yeah, the good news is that the pressure from the user, but also the science community is such that a succeeding mission, a successor mission is being developed, which eventually should go into the operational arena. So
yeah, that's what I'm hoping.
I read from your answer also what basically you let shine through at your presentation at the recent Living Planet Symposium, which means that the observation means that we have right now need under all circumstances to be sustained and quality assured, and that with also the digital, and I'm not focusing now on twin technology techniques, but also machine learning and AI. should support us to sort of help with the data sets that we are getting to more and more.
Yeah.
And
obviously for the and obviously for the oceans, there is a big community building a digital twin of the oceans, and that needs a lot of attention from what we can get from Earth observation, which is kind of where I started my career.
On a final note, because I remember that you were one of the first ones that I met that had built her own climate model. I remember that very well, that discussion we had at ESAC. Where would you see the digital twins, or do you see the different digital twins, digital twin ocean, digital twin land come together?
They have to, of course they do. But we have built in Downforce, we've actually built a digital twin. It's working, it's really interesting, but I would say it's at the micro end. So the way it works is it comes up from the microbiome. It's driven by a very, very different generation of hydrology modeling, which is coming from the health of soil, not just from the terrain and the rock. So it's what the soil is doing to the water, what the land is doing to the water, not just simply, you know, how steep are the slopes. And that affects the microbiome. And then you can build your forecasts and the backcasts and so on. So there's very, very clearly a need for the coastal area where this has to come together. And unfortunately, at the moment, that's sort of dropping out of the system. You know, that's kind of not really picked up. So when we think about the Great Barrier Reef, when we think about these massive nearshore ecosystems, I'm hoping that's the challenge of the real digital twinning.
Yeah.
Excuse me.
I have two more questions that just came through the chat. Bruno Smets congratulates, says, great talk. It provides a very nice overview of the use and further potential on use of Earth observation data. I'm wondering if you can elaborate a bit on how these data, and more particular its uncertainty, parentheses, acuity not always known, are used by official statistics.
Thank you. Yes. I can only really talk at the moment to Australia, because that's the only place where we've sort of gone end to end. Although the UK and a couple other places are moving ahead. Botswana, for example, and South Africa are doing very well. So what I would say is that you need a very open-minded statistics office. That's your first requirement. Second requirement, statistics office that is comfortable with spatial data. Now, we've got quite a few of them who are coming along, Netherlands, Denmark, and so on. When we were doing the Sustainable Development Goals, Bruno, it was very clear there was a huge nervousness because Earth observation was seen as science and statistics was seen as statistics. And please do not mix the two. Okay, so this is a big problem. But the SDG community and the chief statisticians in the UN, myself included, we kept on pushing and saying, you know, in fact, if we move to spatial considerations in the Sustainable Development Goals, then you absolutely are never going to get spatial statistics without doing the raster vector work. You know, you just have to move up here. And what's happened is two things. Either statistics offices have taken in the GIS, like in Mexico, which is fantastic, or two agencies have come together and they basically work side by side. So they've got a letterbox, you know, like, oh, it's spatial, send it to the GIS mapping guys, or, oh, it's not spatial, we'll have it, please. And I think that's going to take some time to work out. So they are being used in official statistics for those countries that have taken the SDGs and the SEA and the SEEA into their system of national accounts. So forests, absolutely. Most countries now, let me just, on that, I'll just conclude. So the NDCs, the nationally determined contributions, as you know, they come in. In the last round that just came in this May, we had, of the 130 or so that come in, 91 of them have identified soil and soil organic carbon within their NDC. Right. And there's no way they're going to be able to do that without using Earth observation. So as they get more and more onto that, then that will be, I think, where it's going to go. The stats people will pick it up and go with it.
I have one last question from Konstantina, who says, thank you for the great talk. Are there any plans to increase/create strong links between native communities and science, especially for remote areas?
Absolutely. So you noticed that the story for the MaO Mara was all about communities, tribal communities, the MaO, the Maasai, the Kalenjin, totally adept. Many of them are never went to school, so do not read and write, but they can use a smartphone, they can collect data, and they are literally, if you go in and talk to them, you would find someone who is completely literate about the Sentinel missions. It's quite extraordinary. So absolutely. And then up in the Arctic, similarly, I just came back from Iceland and sort of talking to, we had a meeting there of some of the indigenous peoples from the Arctic. Same thing, absolutely able to get it. But what is totally, what's different is that the science and the community science come together around a very different spatial geography. And so what you and I would recognize as an Ordnance Survey map or a cadastre is quite often completely unrecognizable to many native peoples. So but when you show them the 3D map, say for example, or a picture from Google Earth, they get it. They see a landscape and they can interpret it. So what Earth observation does is it brings more people, believe it or not, from these communities into the mapping world. And then there's a whole different conversation of naming of landscapes, of bringing things back and so on. So yes, my thanks for that question, Constantina. It was a really great question.
Thank you very much for that answer. I don't see any further raised hand or comment right now. So I think we've reached the end of a very, very interesting afternoon. Jackie, let me thank you again so much for this very interesting insight, for your time, and for being with us. To the audience, of course, I would like to point out that this recorded video of Jackie's presentation will be out as a YouTube video, and it can be found under the Game Changers Seminar tab of the ISI Bern CH website. And while I'm saying that, I'm getting several text thank yous into you, Jackie, which I'd like to forward herewith. And again, many, many thanks for being with us. Next week, we will have the next climate change related seminar. It will be given by Chris Rapley, and it's going to be entitled Creating Agency to Act on Climate Change, which is a real nice not continuation, but further connection to what you showed to us today. Again, thanks a million, Jackie, for being with us, and to the audience and to yourself, have a nice afternoon and evening from wherever you were watching this seminar. Thanks a lot, and bye-bye.
Thank you so much. Bye-bye now.